Alright, what's up guys? In this video, I'm going to pair with some calculus here. We're going to be talking about concavity and inflection points. So as to determine the intervals on which the given function is concave up or concave down, and identifying the inflection points. Okay, so we got our function here. So remember, to get the inflection points, we will take the second derivative and set it equal to 0. And basically what concave up is basically when the slope increases. Concave down is when the slope decreases. And again, concavity is going to be given by the sign of f double prime of x. So let's begin by finding the first derivative. So we got f prime of x. Let's take the derivative here. Looks like we'll get 12x squared minus, 12x cubed, minus 9x squared. And remember, 8's a constant. So that's the first derivative. And then our second derivative will be the derivative of that. Okay. And in that case, if we take the derivative again, this will give me 36x to the second power. And this will be minus 18x. So that's our second derivative. Now to get the inflection points, which I'll write here, we'll take our second derivative, set it equal to 0. Okay. Alright, so I'm going to factor out an 18x to make this easier to deal with. So this would be 18x multiplied by 2x minus 1, and I'm going to set that equal to 0. And again, you can always check whether or not you factored something correctly by distributing it back in. And then we need to determine the value. So we already know that x is going to equal to 0, and then we need to set 2x minus 1 equal to 0. So we'll get 2x. We'll divide both sides by 2. Which will give us x is equal to positive 1/2. Okay? So those are the inflection points. Okay? Now, the intervals for which it's concave up or concave down, again, you can always kind of create a number line if you like. You can say that that's 0. We got 1/2. We'll make it a little better. Okay, so kind of kill two birds with one stone. So what are the intervals on which this function is concave up? Alright, well, for concave up, it's going to be negative infinity, comma 0, union, and it's going to be 1/2, comma infinity. That's the intervals in which it's concave up. Concave down, however, it's going to be concave down on the interval 0, comma positive 1/2. And we've already identified the inflection points. And our inflection points are going to be x is equal to 0, or just x is equal to 1/2. And that's your answer. Alright, pretty straightforward. So if you guys got any questions, please let me know. I'll be more than happy to address it. So we'll see you next time.